So hi everyone and welcome back to the next video. In the last videos we have been considering how to utilize drawing in training situations. I called it the typical flip chart situation, and we put a lot of focus to sketchnoting and drawing in general. In this video and the next one, I would like to put some focus on the Blackboard situation, which probably is more likely to occur during a lecture at university or in school. And in this situation, we probably are not concentrating that much on all the fancy stuff of sketchnoting. Rather, we concentrate on the practicability of how to elaborate complex considerations in front of our audience. So basically, the scenario is the enhanced elaboration, as we can find it, for example, in a maths lecture or chemistry or whatever comes to your mind. So basically, when you're a teacher and you're standing in front of your class, writing on a blackboard or whiteboard, this is what we're concentrating here. So the content to consider probably is very much dominated by enabling of handwriting, how to write formulas, and maybe to complement it also with some sketches and diagrams. And if we try to transfer our teaching approach that we know from on-site situations into a digital scenario, then we typically have two options. The one option is to make use of some digital tools, and the second option is just to rely on pen and paper and get the content digital by means of a camera. And in this video, we will concentrate on the digital setup, so when we use digital tools. And in the next video, I will also show you some possibilities how to stick with handwriting with pen and paper. For the digital setup, there are thousands of tools available, and probably in the end, it's a matter of taste. So just to name a few, we know Bamboo Paper, Evernote, Wacom Notes, of course, Microsoft OneNote, and I think you all have already found your favorite tool. If not, then my suggestion is that before you make a decision on which tool you want to use, that you clarify your personal requirements first. Like in my case, my decision is driven by aspects like the capabilities for organization of different documents. As I'm working on many different computers simultaneously, I'm interested in a good synchronization between the devices. If I use it for practicing in classrooms, then I'm also interested in providing a collaboration capability. And of course, the mandatory aspects are how good is the support for handwriting, and what about the capabilities for sketching and drawings. So I personally, I have chosen Microsoft OneNote, as I'm already using OneNote a lot for basically everything what I do. And so I also try to use this tool in lecturing because I'm already familiar with it. But again, in the end, the question of tool is a matter of taste. And my suggestion is to really clarify your personal requirements and then make the selection of your tool. But for those of you who are not familiar with that, or who are completely new, I would like to show you how I'm doing it. And in particular, I'm showing you how to work in such a situation with Microsoft OneNote. So let's move over to my flip chart, or to OneNote again. And as you already can see here, OneNote naturally provides you a pretty good concept for organizing different documents, notebooks, and stuff like that. But I can close it for now. We don't need it. So then typically we start with some title of a page. Let's call it, for example, this is lecture 42. And the topic of the lecture is, I don't know, let's say it's the charging behavior of a capacitor. Let's assume we have a lecture on electronics. I make it a little bit bigger. I turn it into red, change the size. Yeah, and basically that's it. And now I assume that I want to elaborate with the students together on the charging behavior of a capacitor. So the first thing that I typically do here is to enable some nice handwriting, I decide to show some grid lines. So under the View tab, you can decide on rule lines, and I select grid lines. So this already gives me a good basis for handwriting. And the second thing, in that situation, I would like to start with a drawing of the schematics. And for drawing, we can switch to the Draw tab. And here is one very handy feature. It's already the ruler. So we just can use it, and we can create our schematic like this. Oh, sorry, didn't choose the pen. We could create our schematic like this. And something that is very handy here is the possibility to let your ink automatically change into a shape. So for example, when I'm going to draw a resistor, just finish this one like here, like this one and that one, just to complete the schematic. Something like that. And when I'm drawing my resistor, then I choose ink to shape. And here, my not so nice rectangular is automatically turned into a nice one. Same thing for the voltage source, which becomes a circular immediately. And here I want to have a capacitor. I just wanted to delete the line. This is basically how we draw a capacitor. Need to get the ruler right. This is a little bit uncomfortable, I have to admit, but it basically works out. Okay, then of course we can zoom in to make it a little bit bigger for the students. And now we can integrate all the other things like the signs for the voltage. I forgot to turn off the ink to shape feature. So here we have our voltage. We have the voltage at the resistor and at the capacitor. And maybe we also need to have some current, which is a function from the time. So this is pretty easy, like we would do it on a on a blackboard or a whiteboard. Yeah, straightforward. Then we would like to integrate some formulas. I can select another color, and now I can start elaborating on my formulas. Like I know that the current here is something like a 0 with a negative exponential function. Here we can elaborate further. We can say that tau equals the constants of the resistor value and the capacitor, and we can proceed with the elaboration of our equation. So you see that writing in formulas and stuff like that here, it's pretty much similar like on the Blackboard, so it doesn't take a lot of time. And for the students, it looks basically just as if I was standing in front of them. The only difference is they see me from the front and not from the back writing on the whiteboard. Then you can imagine that we do some further elaborations here, and we end up with a final equation, which maybe is UC is the initial voltage times 1 minus e to the power of ERC, something like that. And if this is the final resolution, then what I like very much here is that you have the possibility to make a shape around it. So to highlight, that's it. And if it's important, you also can change the color afterwards or the size. And this is something which I like very much. So for drawing, we have plenty of options available, something that we don't have in a real Blackboard situation. I also can change, of course, the color of the formulas itself. So now everything is in red. Good. And of course, we also would like to draw some diagram which shows us the charging function itself. So I decide to put it on the right side here. And for the diagram, we also have some additional features. If we select shapes, then you see that you already have predefined diagram axis. So you can make it like that. Want to have it black, of course. That's it. Give it some axis. So this is my time axis. This is the voltage. And now we can further elaborate. So for example, I don't know, we know that we have here some level, which is basically something like the initial value. We have a charging function, which could look like this. We know that's approximately after 5 tau it is charged. So this one is our 5 tau threshold. Yeah, and here we also could write the formula. UC equals U0 times 1 minus e to the power of t tau. And maybe we also give it a shape again. Okay, we can remove it a bit. Something like that. I think you get how it works. And yeah, to structure it a little bit better now, maybe we also can select the whole thing and we can shift it around to wherever we want to have it. So having it in a linear structure is better than for creating a PDF then, and you can follow the flow better. Yeah, so basically you see it's pretty easy. The elaboration, you have an endless paper, you have grid lines. So from my point of view, I'm pretty fine with that. So this gives me pretty much the same capabilities as I would have standing in front of a blackboard here in the classroom. Good, so let's come back, and some final aspect that I would like to mention here with you is, before we close this video, in such a blackboard situation where we are elaborating on some complex content, then this is a situation where we really could benefit from the remote situation. So you could consider to adopt your teaching methodology to a paradigm that we call flipped classroom, which basically means that for such elaborations, you could create some video snippets of this. This is very helpful for the students, because if you think back to your own time in a maths lecture, then probably you were busy with copying whatever was has been written on the blackboard, and you couldn't follow the content. And having such an elaboration as a video makes it easier for the students to hit the pause button, to reflect on how was it, to scroll back a few seconds and stuff like that. So you could create these things as video and then use the time that you have together with your students for some live practice, like giving them examples and they are trying to solve them on their own, or to provide some question and answering. So in this situation, again, I think here we also could benefit from remote teaching scenarios. Yeah, the only thing is we need to get familiar with digital tools and utilization of them, but I think this is a task that can be solved. If you still prefer to work with a real pen and paper, then just jump into the next video where we take a closer look on how to work with real pen and paper in a remote scenario, which is more easy than you might think in the beginning. So see you in the next video and have fun with practicing.